Okay guys, welcome to another video with Number Ninja. Now in this video we are going to be looking at what we call differentiation. Okay, and it's for the year 11 IGCSE Mathematics. So now first, let's start off by looking at how to find the derivatives of functions. Now the functions that we are going to be considering for this syllables IGCSE Maths is mostly polynomial functions. Okay, what we call polynomial functions. Now these are three of the rules of differentiation. Now the first one says that if I have a function, okay, this is my function f of x. So if f of x is equal to a x to the power of n, now dy over dx. Now what this means is that you differentiate y with respect to x. Okay, so we write dy all over dx. So that means differentiating y with respect to x. Okay, or this is also called the derivative of y with respect to what? X. Okay, now but mind you, y must be a function of x. So that's why, so which means y is of course equal to f of x. So y is the function, right? So which means dy over dx now will be equal to what? Now for this function I have here, my y was equal to, I have a x to the power of n. Now the derivative, which is dy over dx, will give us. Now how do I find it? Now you are going to move. Now the law says you are going to move the power. Okay, so the power there is letter n. So you move that power to become a multiplier. So this n now come to the front. Okay, that n is actually multiplying the whole thing. So I have n times a x. Then now you are going to subtract 1 from the power. So basically you have to move the power to the front, okay, becoming a multiplier, then subtract 1 from the power. So which means if I differentiate a x to the power of n, I'm going to get a n x to the power of what? N minus 1. Okay, so this is the first law that you have to know. Now the second law is about derivative of a constant, which is 0. Now this law is basically saying that if f of x is equal to c, now this c is a constant. Okay, now a constant is actually any number. Is a number that does not contain the variable. Okay, so now if for example I have I'm differentiating with respect to x, right? So which means if for example now my y is equal to, let's say, 2y, or let's use 2t, 2t. Now dy all over dx in this case is going to be 0 as well, because y is 2t. Okay, now as far as the function does not contain variable x, this whole thing become a constant. Yes, so if I differentiate the constant, you always get 0. Okay, so if I differentiate a number as well, a number does not have x, I'll also get 0 as well. So that's why dy over dx is equal to what? 0. Okay, don't forget the derivative of a constant is what? 0. Okay, now now for this law, this third one is similar to the first one. Okay, now if f of x is equal to ax, dy over dx. Now that ax, simply the power of n there is 1. Okay, n is 1. So the same way you bring 1 to the front, so it's now 1 times ax to the power of what? 1 minus 1, right? Now this gives us ax to the power of 0. x to the power of 0 from indices is 1. 1 times a is a, so final answer is a. Okay, so basically how do we use this law? In fact, this third law is like it's still the same thing as this first law, but my n here is just 1. Okay, so that basically, if for example now you have, like, let's say you have y equal to, let's say, 4x. Okay, so this is when to use this law here. Y equal to 4x and y equal to ax. Okay, my a is 4, right? So which means now when you compare, now your dy over dx is going to be 4, because if I differentiate, the answer is the a. Okay, so when we now have y equal to 4x, differentiate, the answer is the a, which is the 4. That's the answer. So that'll tell me, now pause the video and tell me, apply this third law. Okay, so if you have y is equal to, let's say, 7x, okay, now what will be dy all over the year? So apply this law and tell me. Okay, you can you can write your answer in the comment section. Okay, all right. Now, having known those laws, now let's now apply those laws in example. Find the derivative of the functions. Now what I have here is, okay, let's solve it here. I have y equal to what? You have x power 4 minus, you have 3x squared, then plus 2, right? Now this function has sum and difference, okay, plus or minus, and of course it's a polynomial function. Now how do we differentiate a polynomial function that has that has a combination of plus or minus? Now you have to differentiate each term, okay, individually. Now I'm going to apply the first law, which is it the first law? No, not the first law, the third law that has ax. Okay, basically it's the first law I'm going to apply. Now don't forget the law. The law says if you have as power 4, you bring the 4 to the front, isn't it? Then you have x to the power of 4 minus 1. This is it. So now I brought this 4 to the front, so it becomes a multiplier. Okay, so we don't have 4x. Then you have to reduce. The law says you must subtract 1 from that power after bringing it to the front. Subtract 1 from it again. All right, so I have 4x to the power of what? 4 minus 1. Okay, now I'm done with this. I'm done with this 1. Okay, now continue. Then I have minus, now this 3x squared. Okay, if I differentiate it, I'm going to bring this 2 over to the front. Okay, now when the 2 comes to the front, it has to multiply the 3. So I have 2 times 3. You put your x to the power of what? 2 minus 1. Okay, then plus, if I differentiate 2, I will get 0. Why? Because 2 is a constant. Okay, don't forget law 2 says the derivative of a constant is 0. Okay, so I differentiated each term basically from here. Now this gives us 4x cubed minus, this is 6x. That's all. So this is the final answer. All right, now let's solve the other one. Now what I have there is y equal to 5x cubed minus 2x squared, then plus 6x. Now if I differentiate this 5x cubed, similar way, bring 3 to the front. Now that 3 have to multiply the 5 when you come to the front. Okay, you have 3 times 5, then x to the power of what? 3 minus 1, then minus these 2 come to the front, right? It multiplies these 2, so you have 2 times 2, x to the power of what? 2 minus 2 minus 1, right? Then plus, I have 6x. Now don't forget the law says if you have ax, if I differentiate ax, I'll get a. All right, so if I differentiate 6x, I should get 6. So I apply that third law here, okay, to get 6, like that. Now my answer becomes, this is 15 x squared minus 4x plus 6. Okay, this is the final answer. So differentiation is not difficult. Just understand the laws, the 3 laws, and how to apply them. That's all. Alright, so I'm going to pick one question from here to solve. Okay, so let us solve number 16 together. 16. So I have this. So now my dy, all over dx, which means the derivative of y with respect to what? X. Now it's going to be now you have 8 over 9 x to the power of 5. So the same way you bring the 5 to the front, so it's now multiplying 8 over 9, right? You have your x to the power of what? 5 minus 1, then plus, okay, you have 1 over 15 x cubed. That 3 comes to the front, then times 1 over 15 to the power of what? 3 minus 1, right? Then plus 0. Why? Because I have 1 over 8. This is a constant, a number, because it does not have x. Don't forget, the derivative of a constant is always 0. Okay, now this gives us 5 times 8 is 40. I have 40 over 9 x what to the power of 4, then plus, now 3 is 1, then 3 is what? 5. 1 over 5 x squared. Okay, that's all. So this is the final answer. I'm done. So now please pause the video. Okay, attempt this the other tasks, so you can solve them in a similar way. Okay, and this. Now what if we have, okay, now let's attempt number 3. Now what if we have 2 brackets? Okay, now 3a, we have y equal to t plus 1 into t minus 1. Now this is not going to be dy all over dx. No, because y is a function of t, as you can see. So y contains t. Now instead I'm going to have dy over what? dt. Okay, now please take note, you are differentiating y with respect to letter t, not x. Okay, so depending on the variable there is what you write here. Okay, now first of all I'm going to expand. Okay, if I expand this, I'll do t times t, which is t squared, t times negative 1, that's negative t, plus 1 times t, that's plus t, then plus 1 times negative 1, that's negative 1, right? So basically you have to expand the bracket first. You have t squared minus 1. This is it. Now, which means now let's now differentiate. So you differentiate after expanding the bracket. Okay, so dy all over dt is going to give us, now I have t squared, so bring the 2 to the front, subtract 1 from the 2 like this, then minus what? 0. Now I differentiated this t squared, I got this. Differentiate 1, you get, because 1 is a constant, you get 0. So my final answer is 2t. That's the answer. Okay, so the same way, you please pause the video. The same way, attempt the other questions, 3b and 3c and the others. Okay, don't forget, you have to expand the bracket before differentiating each term. Okay, all right, now let's move on to the next thing. Now this is what we call second derivative. Now, and that's basically what we call d squared y all over dx squared. Now second derivative comes from the fact that now if you have dy all over dx, now this is called first derivative. Okay, take note, this is called your first derivative. Now if you differentiate once, it's called first derivative. Now if I differentiate twice, that's called second derivative. Okay, take note of that. Now second derivatives come from the fact that you are differentiating how many times? Twice. Okay, So now tell me, what do we call the cube y, the x cube? What do we call that? Please write your answer in the comment section, okay? And also tell me, what do we call the ny, the xn? Put your answer in the comment section, please, okay? Very important. Now for the squared y, the x squared, okay, that is called the second derivative, and I'm differentiating twice. So basically it's like I am differentiating, you know, like this, my dy over dx. This is it, okay? And this gives us the squared y, the x squared. So I'm differentiating my first derivative again, and I'll get this. Now let's see how it works. Now A says find the squared y, the x squared, when y equal to x cubed minus 2x squared. Now what you do is that you have to find the first derivative first. So now let's get the y over dx first. If I differentiate x cubed, 3 come to the front, then subtract 1 from 3 minus 1, right? Then minus this 2 come to the front, it multiplies this 2. So you have 2 times 2, then s to the power of what? That 2 minus 1. Thank you. Now this gives us 3x what? 3x squared minus 4x, right? Now this is the first derivative, okay? Now we are going to differentiate again to get the squared y over the x squared. So basically you are differentiating this your answer, okay, one more time. So if I differentiate 3x squared, these 2 come to the front, so that 2 now is now multiplying 3, right? You have x to the power of 4, 2 minus 1, right? Then minus, now don't forget, if I differentiate 4x, I'm going to get 4, right? Okay, according to this this third law, okay, differentiate ax, you get a. So differentiate 4x, you get 4. All right, now the final answer is going to be 6x minus 4. That's it. Then now for this, okay, you say work out the squared x dt squared for s equal to 3t, then plus half t squared. Now don't forget the reason why we have dt, because s is a what? Is a function of t, right? So basically I'll differentiate once, so I'll find the s dt first. If I differentiate 3t, I should get 3, right? From that third law I just show you. Then plus, if I differentiate this half t squared, these 2 come to the front, so that 2 is going to multiply the half, isn't it? Then the power of t, then 2 minus 1, right? This gives us 3 plus, now this 2 cancel out the 2, okay? It goes away, so I have t power 1, which is t. So basically my ds dt is 3 plus t. Now this is the first derivative. Now we have to differentiate again to get the square s dt squared, right? Now I'm differentiating this my answer one more time. Now differentiate 3 is a constant, right? So I will get 0 plus differentiate t, you get 1. Why? Because you know, if I have y equal to t, this t has power 1, right? Now dy over dt is going to give us that same law. You bring 1 to the front, which is 1t to the power of what? 1 minus 1, right? This gives us t to the power of what? 0, right? And from the law of indices, t power 0 is what? 1. So that was how I got 1 here. So now if you differentiate t, you get 1, okay? 0 plus 1 is 1. So the final answer is going to be 1. That's what we have here, okay? as the correct answer. So it's easy. No, now the same way, pause the video please and attempt this task. Okay, so now for this 2D now you have to expand. For 2A, 2B, 2C and 2D, expand. Okay, expand the bracket first before differentiating twice. Find the second derivative of each function. So now you have to expand this bracket. You do x squared times s cubed, x squared times negative x, then plus 1 times s cubed, then plus 1 times negative x. Okay, now after expanding, you get the expanded form of x, of y, right? Then you then differentiate them twice and you get your answer. So please post your answer please for this question, d squared y dx cubed. Okay, please post your answer in the comment section. I want to see your answer please for this 2D. All right, so I'm expecting your answer in the comment section for this 2D. All right, now lesson 2. Now let's look at how to find the gradient of a curve at a point. Now basically, what is the meaning of gradient? Now gradient, you have learned gradient before. So gradient means slope. Now basically this dy over dx that we are talking about is the gradient. Now this is called the gradient function. Okay, it's called the gradient what? Function actually. So now when you differentiate once, you get dy over dx, right? Now that's actually the gradient function. Okay, now what if I now have a point? Maybe I have a point, let's say at point s equal to, let's say, 1. Now which means if you are asked to find the gradient at a point, let's say s equal to 1, what do? Now after getting your gradient function, now you have to plug in the value of x at that point. So which means after getting my dy over dx, okay, I'll now find dy over dx at s equal to 1. Okay, this gives me an answer. So what I have here is the gradient of the curve at that point s equal to 1. Now let's see an example. Calculate the gradient of the curve. Now my curve here is f of x, that's my function. You have x cubed plus what? Plus x minus what? 6. Now don't forget we have at s equal to what? Negative 1, right? Now okay, yes, that reminds me. Now please pay attention when you see f prime, okay, of x. Now this also means d over dx of f of x. Now f prime, okay, now for your IGCSE exam it can be written as f prime. Okay, now f prime means df of x over dx. Okay, so if I differentiate my f of x once, okay, so the first derivative of f of x is written as f prime. Okay, so they are basically the same thing. Okay, now the second derivative, which is the squared f of x dx squared, second derivative of f of x is written as f prime prime, okay, of x. So now basically I'm saying that the first derivative of f of x is also same thing as what? Also same thing as f prime. Okay, so which means if I write f prime, okay, of x, so this means I'm differentiating the function once, right? Now differentiate x power 3 come to the front, so I have 3 minus 1 here, right? Then plus differentiate x, you get 1. Differentiate 6, you get 0, so minus 0. So now basically my f prime of x is equal to what? 3x squared, right? Then plus 1. Now this is my gradient function. Okay, now the f prime of x is your gradient what? Function, right? Now what you have to do now is to substitute the value of x given to you there. Now at the point s equal to -1, so we are going to get f prime of -1. You get? Now we are going to plug in the value of x as -1. So in your answer you have 3 into what? -1 all squared then plus 1. Okay, so -1 squared is 1 times 3, that's 3, then plus 1, so the answer is 4. So which means that the gradient of this curve, this is a curve, at s equal to -1 is 4. All right, so now the step is easy. Now the first thing you find is the gradient function, which is f prime of x. Okay, then you have to substitute the value of x at that point into your gradient function. Okay, that gives you the final answer. Okay, now I have this other question. Okay, now the function f of x, so my curve or my function is, you have s cubed minus x squared minus 5. Now we are told that it has a gradient of 8. All right, so which means our f prime, okay, f prime of p, because we have a point, it has a gradient of 8, right, at a point p. Wow, a point p. So which means that the gradient of that function at point p, yes, is 8, of course. Okay, so now I say calculate the possible coordinates of point p. So basically, don't forget, point p is a point, and a point must have x and y coordinate, right? So now we are going to find the x and the y coordinate of point p. Okay, that's the task. Now this is my function. Now I'm giving the gradient already, so now we are going to differentiate. If I differentiate once, I'll get the gradient function, right? That's called f prime of x, right? This is my gradient function. Okay, now this will give me 3x squared minus what? These two come to the front, minus 2x, then minus 0, right? 0 because 5 is a constant, right? So my f prime of x is going to give me I have 3x squared minus 2x. Now this is the gradient function, mind you. All right, now we are told that the gradient, okay, is 8 at a point p. So now how do I now find the possible values of p? Now what I'll do is that I'm going to equate. Okay, I will equate f prime of s, which is your gradient, equal to 8, because we are told it is 8. So now you have to equate it, okay, like that. So I have 3x squared minus 2s is equal to 8. All right, now this gives us a quadratic equation. So I have 3x squared minus 2x, then minus 8 is equal to what? 0, right? Now when we solve this, when I factorize this, okay, now 3x squared times -8, you have -24x squared, right? Now think of two numbers, two factors. If I multiply them, I'll get minus 24. If I add, I'll get minus 2. Wow. So my two numbers are obviously 4 and 6. Okay, now 4 and 6, but I should change the sign. So yes, minus 4 and 6 should work. Minus 4 times 6 is -24. Minus 4 plus 6. Okay, so which means I should use plus 4 and -6, right? Don't forget, this is trial and improvement method. Okay, so don't forget that I'm using the factorization method, okay, to solve this quadratic equation. Okay, so obviously I multiplied 3x squared times -8. I got -24x squared. Now I'm thinking of two factors. Okay, this is called the trial and improvement method. Now two factors, if I multiply them, I'll get negative 24. If I add, I'll get negative 2. That's here. Okay, my factors are plus 4 and negative 6, because when you multiply 4 times negative 6, I'll get negative what? 24, which is correct. Now if I add 4 and negative 6, I'll get negative 2, which is correct. So now you are going to write 3x squared, then 3x squared, then plus 4x minus 6x, then minus 8 is equal to what? 0, right? So obviously, after getting your two factors, you have to use those factors to replace the middle term, right? So I hope you all are conversant with using factorization method to solve quadratic equation. Okay, so if not, I'm going to make a video. If you are not what's it called, conversant with it, okay, please let me know in the comment section so that I can make a video on how to use factorization method to solve quadratic equation. Okay, so you can type your response in the comment section. Okay, now we are going to factorize these first two terms. So you bring out only x, so I have 3x plus 4. So now you have to copy and paste the bracket first. 3x plus 4 comes here, equal to what? 0. Then this should be negative 2. Yeah, because minus 2 times 3x, negative 6x, minus 2 times plus 4, negative 8. That's correct. Now this gives us you have x minus 2 is equal, okay, bracket what? 3x then plus 4 is equal to what? 0. Now how do I find the values of x? Now either the first bracket is 0, isn't it, or second bracket is what? 0. Now the value of x here is 2, or now you have to move 4 plus 4 across to the other way. I have negative 4, right? Now the value of x here is negative 4 over what? 3 over 3. So now this gives us the values for x. Now mind you, now these are just the values of x. Okay, now the question says find the possible coordinates of point P. Now, so which means, don't forget, a coordinate must have x and y, right? So which means we are going to find the values for y now. Yes, so now we now when x is 2, so now let's find what y is going to be. So now how do I get the value of y when x is 2? Now you are going to substitute 2, okay, for s into the function, please, into f of x. All right, so basically I have f of 2, right? F of 2 is going to give us this become 2 cube minus what? 2 squared minus 5, right? So 2 cube is 8. You have 8 minus 4 minus 5. So now my f of 2 is basically what? 8 minus 4 is 4, minus 5 is negative 1. Okay, so when s is 2, the value of y is negative 1. So my first possible coordinate of P is s must come first. So you have is 2 comma negative 1, right? Now this is the first possible coordinate of P, this. So now the same way you have to find the second value of y when s is what? Negative 4 over 3, right? So now I will leave that as task for you. Okay, now please do it. So just plug in the value of s into your function, right? We are looking for f of negative 4 over 3. So that now please complete it. Get your answer here. Okay, so whatever you get here is going to be your second possible coordinate of P. So the value of s must come first. So you now write negative 4 over 3 bracket whatever you got there, right? So these are the two possible coordinates of point P. Okay, so this one and this. Okay, so now please complete this calculation. So you can type your answer in the comment section as well. Okay, so I'm expecting to see those comments. All right, so this is your task. Find the gradient of each function at the given values of x. So now the value of x. Now let's solve it together, please. Now the first thing that I'm going to find here is my gradient function, right, which is f prime of x, right? So now you differentiate this stuff. You have minus half. It's going to multiply the 3, right? 3 come to the front, so times 3. This will be s power 2, right? Don't forget the law of differentiation. I move this 3 to the front, so I have negative half times 3. Then subtract 1 from the 3, you have 2. Okay, then plus, if I differentiate x, I'm going to get 1. Take note, differentiate negative 3, you get 0, right? 0. So what I have here is negative 3 over 2 x squared, then plus 1, right? Now we are given a point, so the value of s is 2. Now the gradient of this function at, so you're looking for f prime of 2, right? Yes. Now f prime, the value of s is 2, that's why I wrote f prime of 2. So now you are going to plug in the value of 2 for x into this answer you got here, okay, into your gradient function. So I have negative 3 over 2, then times what? I have x squared. This is now 2 square, right? Then plus 1. Okay, this gives us now 2 squared is 4. Divide 4 by 2, that's 2. Then times negative 3, I have negative 6 plus 1. This is negative 5. This is the final answer, negative 5. So now please pause the video and solve A, B, C, D, and F. Okay. Now same here. This is also a task. Now this task, you are given the gradient. We're given the gradient already. Okay, already. So my gradient here is 5. So now the same way, you want to find the possible coordinate of the point. Okay, so you have to solve it the same way I solved this task. Same way, this one. All right. So now let's solve C together. Let's solve D together. Sorry. Now the first thing I'm going to get is my what? Gradient function, right? Which is f prime of x. Differentiate s. So I'm solving D. All right. Differentiate x cubed. You're going to have 3x squared, right? 3x squared, then minus. Differentiate x squared. You're going to have 2x. Differentiate 4x. You're going to have 4 plus 4. Now this is my gradient function, right? Now we are told that the gradient is 5, so just write equal to 5 like that. Then you now rearrange it. I have 3x squared minus 2x plus 4 minus 5 equal to 0. So I brought 5. Okay, I go to the left, so I have 0 on the right. Okay, now this gives me 3x squared minus 2x then minus 1. Okay, equal to what? 0. So that I'm going to solve this task using my calculator. So if you have this calculator, please, you can use it, okay, to solve this question. So I'll press mode, I'll press 5 for equation, then I'll press 3 for quadratic equation, right? Now the value of my a, now your a means the coefficient of x squared. Okay, my a is 3, you press 3, press equal to the value of b, okay, is negative 2. So b means the coefficient of x, negative 2. Negative 2. You press equal to the value of c is negative 1. So press negative 1. Now you press equal to again. So my x1 is 1. So my first answer is 1. Second answer is what? Negative 1 over 3. Okay. Now, just in case you don't understand what I did here, so I used my calculator to solve this quadratic equation. Okay. So now the first value of s I got was what? Let's check. S was 1 and negative 1 over 3. Okay. So my answer is 1, 1, or negative what? 1 over 3. Now, just in case you don't know how I solved this. Now, I've made another video. Okay. Now, I made an exclusive video of how to use this calculator. This is Casio FX 991 ES Plus. Okay. Now, I made a video on how to solve quadratic equation using this calculator. Okay. Now, I'll leave the link to the video under the description of this video. Okay. Now, please click on it and watch the video. Okay. So the video will teach you how to use this calculator to solve quadratic equations. Okay. Very important. Very important. That saves you a lot of time in the exam. Okay. Now, now that's for that. Then let's now continue. Now the values of x here are 1 or what? Negative 1/3. Now don't forget, we need, you say find the coordinates of the point. So the point must have point P must have x and what? And y. Now we just got the value for x, 1 and this. Now for you to get the values of y, you have to plug in your answer, your s, into your function you got. Into your function. Okay. So now I want you to do that. So plug in the value of s into the function. So you are looking for f of 1. Now f of 1 gives you the value of, now the first point is going to be s is 1, comma, box, value of y. All right. So now the what you get here, f of 1 is what comes here. Okay. So the value of y when s is 1 is what you're going to write here. Okay. So I need you to complete it. All right. Then same thing. So you get the value of f of negative 1 over 3. Okay. Now please complete these. So what you got here, what you got here is going to be the other possible coordinate of the point. So you have minus 1 over 3, comma what? Comma whatever you got here. Okay. So these are the two possible coordinates of the point. Okay. So please complete it, and you can tell me your answer in the comment section as well. Okay. All right. So now let's solve this question together. Number 3. It says find the gradient of the curve with the equation. Now what I have there is y equal to 3x minus 2 into 4x plus 1. Okay, at the point with coordinate 3, 91. Now don't forget, if you have two brackets, you have to expand first. Okay, expand them out. Now you do 3x times 4x, right? That gives us 12x squared. You do 3x times plus 1. That gives us plus 3x, right? Now you do minus 2 times 4x. That's negative 8x. Then minus 2 times plus 1. That gives us negative 2, right? So my curve is 12x squared. This is minus 5x minus 2, right? This is my curve. Now we have to find, now first of all we have to get the gradient function. Now gradient function is basically dy over what? Dx, or I can write y prime. Okay, this is called y prime. So now y prime also means dy over dx. Okay, please take note for your IGCSE exam. Now y prime, which means I'm differentiating this function once, right? So I have 24x, right, minus, so I'm applying the laws of the differentiation. Okay, so I have 24x minus 5, right? Very good. Now we are asked to find the gradient of this curve at this point. Now I have my point here is 3, what 91, right? So basically the value of x is 3, is x, and y is what 91. Now for us to get the gradient at that point, okay, now you are going to use your gradient function I just got, which is what 24x minus 5. Now I am only going to plug in the value of x, not y, because my gradient function only has variable x, right? So I need just the value of x. I don't need the y. All right. Now s is 3, so plug 3 there. You have 4 times 3. 4 times 3 minus 5. Okay. This is 2. This is 72, right? Minus 5. So now the final answer is 60 what? 67. Okay. So that is the answer for that question. Okay, so let's solve this one together. Number 5. So now you are going to solve question 4 and 6 as tasks. Let's solve 5 together. Now 5 says find the coordinate of the point on the curve with equation 3x squared minus 4x minus 2, where the curve is parallel. The curve is parallel to the line with equation negative 2x plus 1. Now don't forget, very important for parallel lines. When lines are parallel, okay, so that means that they have the same gradient, right? So parallel lines must have the same gradient, okay? Now, but this is a curve, okay? This is a curve, mind you, it's not a line, and this is a straight line. So I have a straight line and a curve. Now, but they have the same what? The same gradient. So which means I'm going to equate, okay, because they're parallel. So I'm going to equate, their gradient, right? That's it. So now the first I'm going to get is now for the curve. Let's get the gradient of the curve, okay? Now for the curve, the gradient of the curve is your y prime is equal to, now you don't forget, for the curve the gradient is your first derivative, right? Now differentiate your curve. I have 3x squared, so how will it be? It becomes 6x, right? So I have 6x minus, differentiate 4x, that's 4, differentiate negative 2, that's 0, a constant. Now so 6x minus 4, this is the gradient function for the curve, right? Okay, good. Now for the straight line, let's get the gradient function of the straight line as well. All right. So my y prime here is going to be, now you have to differentiate the straight line. Differentiate negative 2x, you have negative 2, right? Differentiate 1, you have 0, so I have negative 2 only, right? Now what does that mean? Now this means that now this is the gradient function of the curve, right? This is the gradient function for the straight line. So I'm going to equate them, these two things, because they are parallel, so they have the same gradient. That's why I'm going to equate them. So I have 6x minus 4 is equal to negative 2, right? From here now solve for x. So I have 6x is equal to what? If I move negative 4 across, I have 4 minus 2, right? This is 2. So obviously I have 6s is equal to what? 2. The value of s should be what? 2 over what? 6. So I have 1 over what? 3, right? Now the question says find the coordinates. Now when you see coordinates, it means you must find the value of x and the value of what? Y, okay? And it must form a point, right? So find the coordinate of the point. Now let's call the point P, all right? Now how do I finish this? Now I only have the x coordinate, which is the 1 over 3. Now how do I find the y coordinate? Now I'm going to plug in my answer into either the curve or the line. So which means I'm using the line. Let's use the line. So which means at s equal to 1 over 3, let's get what y will be. So I have y equal to negative 2, times 1 over 3 plus 1, right? So I have negative 2 over 3 plus 1. So the value of y is obviously 1 over what? 3. Now the final answer for that question, the point P now is going to have s must come first, 1 over 3, comma, what's my y? 1 over 3 again. Now this is the final answer, okay? Final answer. So which means that now at this point, the curve and the straight line have the same gradient. They are parallel at this point. Yes, very, 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 very important. All right. So now please pause the video and solve question 4 and 6. Okay, you can do them. Apply similar method. Okay, you get them right. Now let's move on to the equation. Equation of a tangent at a given point. Now obviously, what is a tangent? Now if I have a curve, let's say I have a curve like this. Now this is a parabola. Is a what's it called? It's called a quadratic curve. Now a tangent is a straight line that touches the parabola or the curve at only one point. Okay. Now if I draw a straight line, it is not touching. Now if I draw a straight line such that my straight line touches my curve at only one point, just like so. Now let's call the point T. Now this is the point T. This point T is called the point of what? Point of contact. All right. Now this line, okay, is a tangent of this curve, right? Take note. Now I can have cubic curve. Now this is a cubic curve. I can also have a tangent line, okay? So now this is my tangent line. You see? Now the point of contact can be point T as well, okay? Now, so this is the stuff. Now, what we are saying is that the equation of a tangent at a given point. Now, the given point must be the point of contact. Take note. This point T must have x, y, right? Because the point. Your point T must have s, y, right? Very good. So now, basically, we want to find the equation of this tangent line, okay? Don't forget, it must be at the point, okay? Now let's have the example. It says find the equation of the tangent of this curve. Now this curve is quadratic. It has s squared. Okay. Now this is a parabola. So when I draw this parabola, it will look like this. Okay. So now at the point s equal to 1. Now the tangent line can be something like this. My tangent line, don't forget, like that. So now we want to find the equation of this straight line, okay, at this point where s is equal to 1. Okay. Now the first thing I'm going to do here is to find the gradient function. Okay. So you must find the gradient function. That's the first thing you have to do. And what is the gradient function? That means it's just your first derivative, which is f prime of x. So now this is your gradient function, okay? Now differentiate this your function once. I'm going to have, don't forget, these two come to the front, isn't it? It multiplies. So I'm going to have this 2 times half, that's 1. So I have x, right? x, yes. Then plus, if I differentiate 3x, I have 3. Differentiate plus 1, you have 0. It's a constant. So now s plus 3 is obviously my gradient function, right? Very good. Now the next thing we are going to do now is to find, now at the point, let's find the at the point s equal to -1. Now let's find the gradient at that point. So I'm looking for f prime of 1. Okay. So I'm trying to get the gradient at s equal to 1. So you have to plug in the value of s into this your gradient function, right? So s is 1 plus 3. And what's my answer? 4. Now you can see that the gradient at s equal to 1, okay, is 4, right? That's very good. Now, what does this thing mean? Now, please pay attention. You know, the meaning of gradient, okay, or the symbol is m, right? We use m to represent gradient. Now that means that at the point s equal to 1, okay, the value of m is just 4. Exactly, because at the point s equal to 1, f prime of 1 means the gradient, right? So the value of m is 4, because m also means the gradient, right? Thank you. Now we are going to use the equation of a straight line is y equal to mx plus c, right? Now because my tangent is a straight line, take note. Now that's why I'm using the equation of a straight line, okay? Thank you. Now we have the value of m already as 4, you see, as 4. So now plug that in here. So I have y is equal to what? You have 4x plus c, right? Now we have to find the values of what? Of c now. Value of c, and that gives us the answer, okay? Now for us to get the value of c, we have to use the point given to us. Now don't forget, we are given a point s equal to 1, right, in the question. So now I'm going to put that value, so which means I have to find f of 1. Don't forget, f of x is the function, right? This function here. So now you have to find f of 1, okay? So the value of the function at s equal to 1. So now plug in your values. You have half into, you have 1 all squared, right? Then plus 3 bracket 1, then plus what? 1, okay? Now this gives us half plus 3 plus 1, right? Obviously this is 4.5, and this is 9/2, right? 9/2. So which means that the value of the function f of s at s equals 1 is 9/2. So, and this is my y. This is my y. 9/2, right? That's my y. Okay. So my s is 1. My y is this. Now, so we are going to use that. Use that to find the value of c, your constant c. So my y is 9/2, right? Is equal to, you have 4. My s is 1. I have 4 times 1, then plus c. Okay. So basically I have, this is 4 plus c, right? So I have now this is 4, this is 4.5. 4.5 on the left, then minus 4, right, is equal to c, right? So I only change this 9/2 to a mixed fraction, right? I took 4 across. This is half equal to c. So my c is half. Now the equation, because we have to find the equation, right? Now the equation of that tangent line, okay, is this. Now is equal to y equal to 4x plus your c. Our c was half. Now this is the final answer, okay? So obviously, let's go over the step one more time. Now the first thing I did was to get my gradient function, which is f prime of x, s plus 3. Then I calculated the gradient at the point s equal to 1. So I plugged in the value of x into your gradient function, which I got 4. So, and that gave me my m as 4. Then I used the equation of a straight line, because the tangent is a straight line, okay? That's why I'm using this equation of a straight line, okay? Then now the next thing I did was that I had only the value of x as 1, so I needed to get the value of y, okay? Which was why I went here, I plugged in the value of s into your function, okay? And that gave me 9/2. So 9/2 become my y. Now I use that to get the value of c. Okay, so Now that gives me the final equation. So y equal to 4x then plus half. You can say that is the answer over here. So and it's correct. That's the answer. Okay. So now this is how we find the equation of a tangent to a curve at a point. Okay. Thank you. Now please pause the video, and attempt this task. For the function f of s equal to this, calculate the gradient function. Now don't forget the gradient function, okay, is f prime of what? F prime of x. Okay, that's it. So which means you have to get f prime of x. That's the gradient function. Okay, now b says calculate the gradient of the curve at this point. So which means after getting your gradient function, you have to just, now your gradient function is going to contain only variable x, right? Yes, it contains only variable x. So which means the only thing you need here is just this x, s as 2. You don't need this negative one. You don't need it. The only thing you need here is just x, s as 2. That's all, because your function will contain only x, right? So now you are going to find the f prime of 2, basically. That's the answer to that part. Then now we have a tangent is drawn to the curve at point A. What is the gradient of the tangent? Wow. So now the gradient of the tangent is also the same as what you got here, okay? Yeah, now this same answer I got here, okay, is your answer. So that is the same answer, okay? Because the gradient of a tangent at a point is the same as the gradient of the curve at that same point, okay? So whatever you got here is your m. So that's your m, right? Then this says calculate the equation of the tangent. Wow. Give your answer in the form y equals mx plus c, of course, because it's a straight line gradient, right? So you can use this approach I use here the same way to get your equation, okay? So now please solve it. You can post your answer as well in the comment section, please. So I'm expecting to see those comments, those answers, okay? Now on to lesson 3. Wow. Now this is what we call stationary point. Okay. Now what is a stationary point? Now a point at which the gradient of a curve is 0, okay, is called a what? Stationary point. Okay. So when we say stationary point, we mean the point where the gradient is 0. Very important. So the gradient must be equal to 0, okay? Must be equal to 0, okay? At stationary point, okay? Very, very important. Now, what does this mean? Now the other name for stationary point is also called turning point, okay? So we can also call it turning point, okay? So it's called turning point, or what? Stationary point, okay? Now don't forget the gradient must be equal to what? 0, okay? Now what that means is that my gradient function, which is the y over the x, must be equal to 0. Yes, at turning point. Now this is very important. So which means at the turning point or stationary point, your dy over dx must be equal to what? 0, okay? Now the reason for this is because now if I have let's say I have a parabola, okay, like this, for example, my parabola. This is my graph, for example. Now the turning point here, now this is the turning point. Now this point here, okay, now the point where the parabola like turns, you know, so let's call that point T, right? Now, you can see that at this point here, okay, the gradient there is 0. So your dy over dx is 0 because that's where the parabola is like turning, you know. So which means that this point here is called a minimum. Is called a minimum turning point. All right, or we call it local minima. Local what? Minima. So we call it local minima or minimum point. Okay. So this is of course a minimum turning point. Okay. Now, but okay, now same thing happens if I have parabola like this. Now my turning point has to be here, right? Now the point where your parabola like you know turns, okay, that's called turning point or stationary point. Okay, now quarter point T. So my gradient at that turning point, my gradient there must be equal to 0. Take note, very important. So now this one is called a maximum point, okay, because it's above. Minimum point because it's below, right? So my turning point here is called a maximum point, or it's called a local. We call it local maxima. Okay, it's called local maxima. All right. So now basically, what that means is that we have different types, okay, of what's it called, stationary point, okay, different types. So now basically there are 3 types. Yes, 3 types. Now, but for your IGCSE exam, IGCSE Maths exam, so you are going to be examined, or you'll be examined on just 2 types, okay, which are what? Which are the maximum, they are called the maximum point. Maximum point is also called, we call it local maxima, okay, local maxima. Then, or okay, we also have what we call the minimum point, or it's called local what? Local minima. Local minima, very important. So now basically, now for IGCSE exam, you'll be tested on just these 2 types, okay, maximum point and minimum point. Okay, now you don't need this third one, that's called point of inflection. You don't need that for IGCSE exam. Okay, now basically, what is a point of inflection? Now a point of inflection is like this point D. Now you can see that. Now if you observe clearly, now this point A, this point A over here, okay, is a maximum point because the gradient is, you know, is okay, is decreasing, right? Decreasing, so it's a maximum point, and also is above. Now this point B over here is a minimum point, right? Because the gradient is what? Okay, it is increasing, right? This point C is a maximum point as well. Now this point D is called the point of inflection. Why? Now, why is it called point of inflection? Now, it's called point of inflection because now please pay attention. When this curve is going down, okay, along this part, now the gradient is decreasing, right? You can say it's decreasing because the curve is like is going downward, right? Now the gradient is decreasing, right? Very good. Now if you check this at this region, the gradient is still decreasing. Now the gradient is still decreasing. So now that means that a point of inflection is like a point where in which, now before point D the gradient was decreasing, right? And after point D your gradient is still decreasing. So if I have a point in which your gradient was decreasing before and is still decreasing after that point, that point is called the point of inflection. Okay, that's it. Now if you look at this point A now, okay, my gradient here is increasing. Yes, it's increasing in this region. Now when it got to point A, you see the line is now going downward, right? So my gradient here is now decreasing. Is that clear, please? I hope you understand this concept very well. So my gradient was increasing before point A, then after point A my gradient was now decreasing, right? So now that's why this point A is a maximum point. Now for point B, your gradient was decreasing because it's going downward. After point B, your gradient is now increasing because it's now going upward, right? So now point B is a minimum point. Now for point C, your gradient was increasing. You can see it's going upward. After point C, your gradient is now decreasing. So this is a maximum point now. But for point D, your gradient remained the same. So it was decreasing before point D, and it is also decreasing after point D. Now that's why point D is called point of inflection. Okay, so basically a point of inflection is a point in which a curve, like a curve, was decreasing, okay, and it's also decreasing, or if it was increasing and also increasing, okay. So the behavior of the gradient does not change. Okay, that's called point of what? Inflection. Okay, so please, you can tell me in the comment section if you understood my my explanation for point of inflection. Okay, all right. So now, but for IGCSE, like I said earlier, you only need to know maximum point and minimum point. Very, very important. Now this is very important. This is called second derivative test. Now this is a test. Now this test is used to determine, okay, it is used to determine or to check whether a stationary point, okay, is a maximum or a minimum. Okay, so now if I have a turning point, okay, or a stationary point, for example, now how do I check, how do I know if that turning point is a maximum turning point or a minimum turning point? How do I know? That's when I apply this test. Okay, it's called second derivative test. Now this test is very, very effective, yes, in checking. Now the idea here is that, okay, now if you're, so which means you have to differentiate, of course, second derivative, so you must differentiate twice. So you must first get your d squared y over the x squared, right? Now the idea is that if after you get your d squared y over the x squared, now if your second derivative is less than 0, so which means that if your second derivative is negative, okay, negative, that's when it's less than 0, right? Yeah, so now that point is a maximum point. That's it, maximum point, or we call it local maxima, right? So I'm saying that if your second derivative is less than 0, or if your second derivative is negative number, like -2 or so, that means your turning point is a maximum point. Okay, now but if your second derivative is, now I have, if my second derivative is greater than 0, now this means is positive, right? So if your second derivative is positive, that means what you have there is a minimum point. That's all. So just have that in your mind, please. Okay, that's how to use the second derivative test. Very important. So these are what you need. Okay, now let's now have an example. Now don't forget, at a stationary point, your dy over dx must be equal to what? 0, right? Don't forget that. So which means at stationary point, your dy over dx must be equal to what? 0, right? Good. Now let's have this question. Now I have a graph has equation this. So my graph has an equation. I have 1 over 3 x cubed minus 4x plus what? 5, right? Nice. It says find the coordinate of the stationary point on the graph. Now what I have to do here now is that I'm going to find dy over ds, right? That's the first thing you must get. So now this is your gradient function, right? Now if I differentiate 1 over 3 x cubed, this 3 come to the front. You have 3 times 1 over 3, you now do power 3 minus 1, right? Then minus differentiate 4x, you have 4. Differentiate 5, you have 0 because it's constant, right? This 3 cancel out the 3. So obviously I have x squared minus 4, right? Good. Now this is my gradient function. Okay. Now, but don't forget. It says find the coordinate of the what? Stationary point. Don't forget at stationary point. Okay. What should be the value of your dy over dx? 0. Thank you. So which means your dy over dx have to be equal to what? 0, right? Now for that reason, I'm going to equate this my answer I got here, what I have here. Okay, so I have s squared minus 4 is equal to 0. Okay, that's it. Now if I solve this, basically I have s squared is equal to what? 4. Okay, now if I take square root of both sides, okay, so which means the value of s is going to be what? Plus or minus 2, right? Very good. So which means the value of s is either 2 or what? Negative 2, right? Now these are just the values for x. So now we need the values of y. Okay. So now obviously, how do we get the values of y? Now you have to plug in these answers, okay, into your original function. Okay, you can say when s is 2, you have to find the value of y by using this your original function, right? So when s is 2, the value of y is negative 1 over 3, right? Now that gives us the first coordinate. So s is 2, comma, y is negative 1 over 3, right? So now this is your first point. You can say then you have, and when s is negative 2, okay, do the same thing. So find the value of y. You have this. So negative 2 for x, and y is 10 whole number 1 over what? 3. So now this gives us the coordinate of the two what? Stationary points, right? So I have these two. Now these two points are my two stationary points, okay? Now but we have to now check which one is a maximum point and which one is a minimum point, okay? Now that should be the next thing that we should do. Very good. Now it says determine the nature of each stationary point. Now obviously, now in your exam you will be asked to check or to determine which one is a maximum point or a minimum point. Now how do I solve that? Now don't forget what I have there is don't forget our first derivative, our dy over ds was what? It was x squared minus 4, right? Thank you. So now we need that. So dy over ds was x squared minus 4, right? Now I'm going to use the second derivative test, right? The test. Very good. So which means I have to differentiate one more time. So I will get d square y over what? Over dx square is equal to what? Now differentiate this again. So you are going to get only 2x, right? Because 4 is a constant. So I have only 2x, right? Thank you. Now, we have to now plug in. You plug in the values of x. Don't forget the value of x we got here were what? 2 or negative 2, right? Very good. So now we have to plug in those values. So you now do at x equal to 2. Let's see what d squared y over the s squared is going to give us. Okay. So now plug in 2. You now have 2 times 2, which is 4, right? 2 times 2, which is 4. Now you can see that 4 is greater than 0. All right. Now obviously, now from the test, don't forget, if your second derivative is bigger than 0, that is a minimum point, right? Very good. So which means now this is a minimum point, or is a local minimum. So this is a minimum turning point. Okay, minimum point. So now same way we can check the other one. Okay, the other value of s we got was what? Negative 2, right? So now plug that into your d squared y dx squared. So you have 2 is now multiplying what? Negative 2, right? And I have negative 4. Now negative 4 is negative, so it's less than what? 0. Okay, now this is obviously a maximum point. This is a maximum point. Why? Because of the test, right? The test. Good. Don't forget, if your second derivative is less than 0, it's a maximum turning point. Okay, now for that reason, so which means that they say determine the nature of each of the stationary points. Now what that means is that don't forget, I have 2 stationary points here. Okay, I have this one and this. Okay, don't forget we have that at s equal to 2, that one is a minimum point. So which means that this point here is the minimum point. So that is my minimum point, this one, and this one here is my maximum point. Okay, that's all. So now these are what you are going to expect in your IGCSE exam. Okay, now you'll be asked to find the what's it called, stationary point, and you'll be asked to check which one is a minimum point or a maximum point. Okay, so now this is your task. Now please pause the video and attempt the task. Okay, now we say find the turning point or point. So which means sometimes the turning point can be only one. Okay, we can have only one turning point. It's possible. You know, for a parabola, this one, oh, that's not fine. Now for a parabola, it has only one turning point, which is this. Okay, turning point. So that's point A. Now, but for a cubic curve like this, cubic curve, it has 2 turning points. So now this is a maximum point, call it point A. This is a minimum point, point B, right? Now this point here, point C, this is my point of inflection here. All right. So now that means a cubic curve have more than one turning point. All right. So you have to find the turning point on the following curve, and now it says explain whether each point is a maximum or a minimum. Okay, so I want to solve. Let me solve on one for you. So obviously you do it the same way as the last task. Now let me solve which one? Let me solve K. Now don't forget, if you have 2 brackets, you have to expand for. Okay, if I expand that, you do s times x So I have y equal to, I have x squared. You do s times plus 5, that's plus, plus 5x. Negative 5 times x, that's negative 5x. Negative 5 times plus 5, you have negative 25, right? Now the equation of my curve is just s squared minus 25, right? That's it. So now the next thing I'm going to get is my gradient function, which is y prime. Differentiate this stuff once, you get 2x, right? Yes, 2x. Now this is my gradient function, right? Good. Then now don't forget at turning point, okay, at the turning point, so what should be the value of the gradient? Is 0. Very good. So your y prime of x have to be 0, okay, at turning point. So which means that gives us this, your gradient function, which is 2x, must be equal to 0. All right, so the value of s divide 0 by 2, that's 0. Wow. Now this is a special case. Now because I have only one value of x, so now this curve has only one turning point. Exactly. So if you have more than, now in fact the number of values of x you have, okay, is the number of turning points you're going to have. Okay, so I have only one turning point in this case. Okay, now obviously we are going to check. Let's now check if that turning point is a maximum or a minimum. Okay, so now I'm going to find y prime of x. Don't forget y prime, okay, also mean the same thing as what? The squared y, the x square. Okay, they are the same thing basically. Okay, the same thing. Take note of that. So now basically I'm differentiating this function one more time. Differentiate 2x, you get 2, right? So now you can see that the value of x has vanished. Now this 2, now you now check, because 2 is greater than 0, of course. So now this is a minimum. That's a minimum turning point, or is called a local minima, right? So which means that this turning point here is a minimum turning point. All right, now but I'm not done, because it says find the turning point. So I only have the value of x, so I have to get the value of y, okay, because it must be a complete point. Let's say point P must have x and y, right? So I only have the value. I have the value of x, which is 0. The value of y I've not yet got it. So which means, how do I get the value of y to get my complete point? You have to substitute the value of s back into your function. Okay, so now you can do that one as tasks. So now you do it. Find the value of y when s is 0. Okay, so that will give you your complete turning point. Okay, then, and that turning point of course is a minimum, yeah, from the test. So with that you can answer your other questions here. Okay, all right. Wow. So now we've come to the end of this lesson tutorial for differentiation. Now this lesson is very comprehensive. Now this is all you need to know for IGCSE differentiation, IGCSE Maths calculus. Okay, so if this video really helped you to conquer those differentiation problems for IGCSE Maths, okay, 0580 Maths. Now please subscribe to the channel. Don't forget to like the video and also share. Please share the video with your friends, okay, so that everyone can benefit from this tutorial. Okay, now thank you. See you in my next video.